In this problem, in a Young's double slit experiment, a combination of two glass wedges A and B having refractive indexes 1.7 and 1.5 respectively are placed in front of the slits as shown in the figure. The separation between the slits small d is 2 millimeter and the shortest distance between the slits and the screen is capital D is equal to 2 meter. Thickness of the combination of wedges is T is equal to 12 micrometer. The values of L as shown in the figure is 1 millimeter. Neglect any refraction effect at the slanted interface of the wedges due to the combination of the wedges. The central maximum shifts with the respect to O is central maxima. That is the condition for central maxima. The path difference is equal to 0. That's all. That is the clue in this problem. Okay. Now, wedge effect we have to consider. See here, the wedge is like this. For proper understanding, I am drawing it in a big way. So this is the wedge. This is A and this is B. This refractive index of the middle of wedge A is 1.7. That of B, refractive index of B is 1.5. That is the refractive index of the middle of those wedges. Here, from the top and bottom, 1 millimeter distance is left, and this is the position of slits S1 and S2. The distance between slits is given as 2 millimeter. From the wedge to first slip is 1 millimeter. From lower wedge to the second slit is 1 millimeter. So total 4 millimeter. So the height of the wedge is 4 millimeter. That's what given. And the thickness is 12 micrometer. When light is coming from S1, it has to go in this way. So it has to travel through two media B and media A. How much distance it is traveling through this media is very important. So here, by using the similar triangles concept, we can calculate this distance is 3 micrometer, this is 9 micrometer, this is 9 micrometer, and this is 3 micrometer. These are the distances through respective materials. So whenever the light travels from material having some refractive index, we can calculate. See, the concept is this is S1, this is S2. The light ray is going and falling on a screen at P. Another light ray coming from S2, it is falling at P. So at the middle, this light ray is also reaching P. So this is angle theta. From P to the center of central bright is Y, and from slits to the screen distance is capital D. This capital D is given as 2 meter. Right, this Y we have to calculate. Shift. So because of the presence of this wedge made up of two different materials having two different refractive indices, this central maxima shifted to P, right? So what is the concept of this central maxima? See, let us take the S1P as L1 length and S2P is L2 length or distance, whatever it may be. So here the optical length, the optical distance, what is the formula for optical distance? Optical length formula is equal to refractive index into thickness. That is the formula for optical distance. Here I have written optical length is equal to refractive index of that material into T. So it is going through various materials, so we will calculate optical distance. So optical distance, see, central bright condition for central bright is delta x is equal to 0. There shall be no path difference. That's why these two paths must be equal. So optical distance from S1 is equal to optical distance, optical length from S2. So let us calculate. First one, this is L distance, L1 distance minus thickness of the wedge is T plus when light is, see here, bigger one, when light is traveling to 3 micrometer distance, the optical distance, optical length or optical distance traveled by the light here from S1 to here is 3 micrometer, that is the thickness, into refractive index. Which material it is? B. B refractive index is 1.5 plus, now it has to travel 9 micrometer. Refractive index of A 1.7, that is equal to, so that is equal to the optical path traveled by the light from S2 to P, that is L2. I have given L2 minus T. This is the thickness of the wedge. And see the second S2, 9 micrometer it has to travel in B. So plus 9 micrometer into B refractive index is 1.5 and plus this now 3 micrometer distance it has to travel through A refractive index is 1.7. So the condition for the central bright we have written. So let us simplify these values. That implies L1 minus T plus 15 threes 45. So this is 4.5 micrometer plus 9 into 1.7, that is 15.3, that is equal to L2 minus T plus 9 into 1.5, that is equal to 9 5s are okay, 13.5 micrometer plus 1.17 threes 51, so 5.1 micrometer. That implies L1 minus T plus 15.3 plus 4.5, 19.8 micrometer is equal to L2 minus T plus 18 plus 5, 15.5 plus 5.1, 18.6 micrometer. Now I will send this L2 minus L1 that side. So what happens? It becomes L2 minus L1, that is equal to 19.8 minus 18.6, that is equal to 1.2 micrometer. So this we called as a path delta x, path difference, L2 minus L1, that is equal to delta x is equal to 1.2 micrometer. See here in this, let us revisit the diagram. In this diagram, this distance is called delta x. This distance is called delta x, and this is the theta. So what is the formula for delta x, the path difference here? D sin theta. So D is the distance between the slits. D sin theta, I'll write here. Yes, now it is visible. D sin theta delta x is equal to 1.2 micrometer. But theta is very much less. So what we can write? Sin theta is equal to tan theta, because sin theta we don't know the hypotenuse value, so tan theta I have taken. So D tan theta is equal to 1/2 micrometer. So let us calculate the tan theta here. So let us revisit the diagram. This is theta, tan theta, opposite side y by adjacent side D. So I can write the same thing here. So D into y by capital D is equal to 1.2 micrometer. Y we have to calculate. Then D value is 2 millimeter given, into y, D is equal to 1 meter. So this millimeter I will convert into 1.2 micrometer. So all conversions I will do. 2 millimeter into y by 1 meter is equal to 1.2 micrometer. So here this 10 to the power of minus 3 and 10 to the power of minus 6 goes. This minus 3 will be here. This is D is equal to 2 meter here. So here this is 2. So 2 will cancel. Capital D is equal to 2 meter. See, capital D is equal to 2 meter. So here y is equal to 1.2 10 to the power of minus 3. So millimeter. This is the shift in the central maxima. So for this question number 14 in section 3, the answer is 1.2. Already they mentioned millimeter.